So let's hear it out for Jon Pretty.
Thank you. Thank you very much. Welcome everyone. Good to see so many of you here. Bienvenue pour les francophones. Is there anyone here from Quebec? Welcome. One person, 2, 3, 4. Now you're all coming out. I'm seeing all the hands going up. So yeah, good to see you here. And what a wonderful venue, Alejandro. I was here for Scala up north. Was it 3 years ago? 4 years ago. 4 years ago. And I was in a sort of a daze because I had just finished running my own conference in the UK, Scala World. And I was totally exhausted. And I had a flight sort of the next day over to Canada from the UK, and the venue that year was not nearly as impressive as this one. So I'm super excited about this, and hopefully you won't be too distracted by the background. So I'm going to talk today about the future of Scala as I see it. The precedent has been set for technical difficulties today. And maybe you will be able to get the visual cues from the background I've chosen here. Because I don't know if you noticed earlier this year, there was an announcement made that the Dotty compiler, which has been under development at EPFL by Martin Odersky for the last, I think, 4 or 5 years, will become Scala 3. And this is going to be a major shift for all of the Scala community. So I'm going to talk for a little bit about some of the features in Scala 3, some of the things that you can look forward to, some of the things I'm looking forward to. And these will be new ideas, some of them very advanced, and I don't expect all of them to make sense to everybody. Some of them actually quite simple and quite nice syntactic changes. And after that, I'm going to tell you a little bit about my ideas, my contributions to where the future of Scala will go, and how I think some things will be a little bit different in maybe a year or so, and that will be some live coding. So I'm nervous about that. Right. So Scala 3. One of the new features is first-class syntax for enumerations, and in Scala 2, I'm sure you're very familiar with code that looks a bit like this. We need 4 lines of code to define what is effectively a simple enumeration. It's a color. It can be one of 3 possibilities. Each of these is an object, and they all inherit from a sealed trait. So not particularly complicated, but it's more verbose than it needs to be. And in Scala 3, we can reduce that to a single line. We use the new enum keyword, and we simply define the cases there. So that's simpler. That's, I think, as simple as we would want that definition to be. And that desugars to basically the same thing as you have in Scala 2, except we just don't need to write the long version. But it goes a bit further. So I don't know if anyone's looked at the definition for list in Scala 2. It looks a little bit like this. It's, again, a sealed trait, but it has a sealed object and a sealed class. So it's either the empty list, or it's a value joined to another list. Cons is actually written in the as a double colon, but I've written it here as the word cons. And we've got lots of things going on. We've got type parameters here. We've got covariance. The same type parameter appears here, 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 and here. We're extending the list in both of the branches of the disjunction. It's quite complicated, I think. But this can actually be written in enumeration form in a much simpler way. We can define it like this. We don't need to repeat the t type parameter there. We don't need the extends clause. This, I think, once again, is much closer to what we would imagine is the problem we're trying to solve. The smallest, least boilerplatey version of what we want to write. And we can do this with all sorts of enumeration style or ADT style code in Scala 2. We can convert it to this format. And I think that'll be a lot easier to read. We can also add methods if we wanted to. So we can define a size on the list. Here I'm defining it in the case where it's nil, it's the empty list, so it's length 0. And if it's cons, then we're going to add 1, which is the one element that cons introduces, plus whatever the size of the tail is. We have to write this in pattern match form because we no longer have the ability to put different methods with virtual method dispatch on each of the cases. So that is one change, or one restriction, but not really much of a constraint for most things that we'd like to do. So the second one, type lambdas. How many people here have encountered type lambdas? Very few. The reason is probably that they're quite complicated. They look a little bit like this. So this is a way of saying I want a type constructor. I want to define something which, if I give it a type, just one type, it will give me a type back. So if I give it, for example, an int, I want this to give me back an either of string, comma, int. And the int is the same int that I gave it. This is constructing a new type from an existing type. So we call that a type constructor. And the problem is that either is a type constructor, but it takes 2 parameters. And we often want to just give it a single type parameter and get a type back. And that doesn't work. We need the syntax to allow that to be used in a position that expects a single type parameter and not 2. So this is the syntax that we arrived at in Scala 2. And this was more discovered than designed. This is a combination of a variety of different features of Scala. It's got a type projection, which is this hash here. It has an anonymous type with a type member, which is a higher kinded type. And it's really complicated, but it would be almost impossible to design Scala that had all of those features, but somehow forbid the possibility of defining type lambdas. So this was discovered in Scala by Jason Zaug. He discovered it was possible to write these type lambdas. But I think you'll all agree the syntax here is quite horrible. We've got 3 different layers of parentheses, different kinds here. And each one is necessary. We can't get away without them. Now in Scala 3, we have, this is an example of a usage. So if we wanted to create a new functor, a functor takes a type constructor with a single type parameter, and then we have to substitute this in the position there. Instead of just writing list, which we could do. We could write list. We can get a functor for list, but in the case where it's something more complicated, we need that type lambda. And in Scala 3, we just write this. And this looks a lot more like a lambda at the value level. A lambda at the value level takes a value, and it returns a value. This is taking a type, and it's returning a type. So once again, it's more similar to what we would imagine is the problem we're solving. Less boilerplate, more clarity. And that's what it would look like in an actual usage. There's some associated syntax with type lambdas in Scala 3. This is Scala 2 code. Has anyone seen code that looks a bit like this? There's plenty of it in the collections library if you dive deep enough. What this is saying is this is a very trivial method. It's just going to get the head of a sequence of some type. And we pass it a value, and what the compiler will do is it will infer the type col with the constraint that col is a subtype of sequence, and it will at the same time infer what the type t is. So if we passed it a list of integers, this would get the head of that list, ignoring the empty list, and the return type would be an integer. What people often write is this. Did you spot the difference? We have underscores here instead of the s type parameter. Does anyone know what the return type of this is? The return type is any, which is not what we want. If we pass this a list of ints, then we would expect the head to return a list of int. But the problem is, in Scala 2, there's nothing, if we use these underscores instead of these type parameters here, there's nothing which binds the type parameter of the sequence to the type parameter of the collection. So if this is list of int, this is sequence of I don't know what. and hence it comes out as any. So this is a programming bug, but it's something the compiler's not really helping with. Now in Dotty, we get this more concise syntax where we don't even need to specify the type parameter. The type parameter on col can be inferred from the fact that sequence is a type constructor. And so this will return an integer. So this is the compiler trying to save you from a common trap. So another feature, implicit function types. This is something that Martin Matursky has spoken about a few times in recent talks at Scala Days. And the examples he gives are quite simple, but they involve side effects and object construction. I don't like examples that involve side effects so much. So I've got an example which doesn't use side effects, but is also not simple. This relates to a library I wrote a while ago, which you can hear me, good. This relates to a library I wrote which adds type level constraints on an asynchronous graph of computations. So it took me a whole talk to describe this last time I tried, so I'm not going to explain that now, but there's some code here which is the core of what that library impromptu did. But at the use site, and this is the slide to look at in more detail. With impromptu in Scala 2, you could write code like this. We could define a block which asynchronously adds 52 to 200, and in parallel, asynchronously multiplies 2 by 3. It's a terribly inefficient way of doing that, but hopefully it illustrates the point. And then once both of those two have finished in parallel, we will then use the result of that to divide one by the other, and then we'll get another result from that. Now this is quite nice. It allows us to define graphs by defining their dependencies and then operating on those dependencies. And the type level constraints I talked about are the fact you can only access the value, which is this apply here, of a value which is known to have been evaluated prior to entering this. Now, the syntax is quite nice apart from one thing which always annoyed me, which is that you need to specify this lambda here. We need this boilerplate in every single time where we're... this is sort of the proof that these two have completed, and the proof is derived from the types of these here. But it's boilerplate, and therefore I don't like it. In Scala 3, we can avoid that by using an implicit function type. And this lambda, which is still a lambda, except we don't need to write it as a lambda with an implicit value, because the implicit is not actually used explicitly. So we can actually move that to the definition site, and by adding this implicit keyword here, the type of this gets inferred, rather than just being a value, it gets inferred into a lambda. And the bottom line is we get the nice syntax. So that's why I like this example. So many people, I think, will have encountered type parameters on methods and some annoyances relating to them. Imagine you had a converter type class. By the way, how happy are people with type classes in general? So, who has used type classes? Probably half people. So type classes give you a way of providing ad hoc behavior on certain types. So I'm going to define a type class which will convert from one type to another. It's pretty basic. It's only got one method here. And I'll define a couple of examples, string to int and string to double, which convert a string to an integer and a string to a double. And we'll just ignore possible exceptions for now. But these will have the obvious implementations. And we can define a helper method. This will convert from a value, it will find the implicit converter in scope. It'll find the converter with the appropriate type, and it will just call that, and we'll get the converted value back, hopefully. Now, if we were to call convert with the string 42, we would get an ambiguous implicits error in Scala 2. And the reason is that I provided two different, equally applicable type class instances, one that converted it to an int, one that converted it to a double. And I didn't give any way for the compiler to choose between them. What we would have to do in Scala 2 is additionally specify the type parameters. But the annoyance for me is that we have to specify string as well, even though we can completely determine that that is a string. We would prefer just to specify the int. And that's what you can do in Scala 3. We can define this in much the same way. And we can just specify that the to parameter, you do have to give it a name. You do have to specify which parameter you are specifying. But we can say we're converting to int or converting to double. And this would then compile. This is obviously more of a problem if you have many type parameters rather than just two. And you want to tell the compiler what one of them is, but have the compiler infer the others automatically, which is quite a common case. This, by the way, doesn't compile. It would be nice if we could define an either, where we infer the right branch of either to be int and the left branch to be string. That's not valid syntax yet, but maybe it will be. Excuse me. So a more recently added feature is erased terms, and this is common in method definitions like this. If we want to do some action, and we define it in a generic way, and we want the constraint that the first value, or the type of the first value, is a subtype of the type of the second value. What we can do is add this constraint here. We want the constraint that there's evidence that T is a subtype of S. Don't worry about why we want that constraint, but occasionally we do need to know that. Now we could actually specify a type bound on S here, on T, that T is a subtype of S. That would be possible, but that would actually change the values that get inferred for T and S. So the reason we use this implicit evidence instead of specifying the bound is that the evidence is checked after the types T and S are already inferred. So we infer T and S from the values and from just the values, and then we check the constraints rather than making a choice of T or a choice of S that guarantees that the type bounds are adhered to. But the problem with this is that when this compiles down to Java, it becomes something like this. It becomes a method with three values, three parameters. And the evidence, even though we never use it in the body of the method, it becomes a parameter. And there's a performance hit with that. With Scala 3, we can say that's erased. We can erase that third and final type parameter, which will guarantee that in the body we never use it. We're not permitted to use it in the body. But it means that when it compiles down to Java, it's completely erased. It's not there. The additional value is not visible. And the constraints mean that we can't use the evidence in the body of the parameter, though I've done it there, because we are allowed to use it in the case where we're using it in a parameter that is itself erased. So we can transmit that evidence, the T is a subtype of S, through some number of method calls, as long as in every case it is erased. It's never materialized. And we can also define some evidence. This will compile down to nothing, no bytecode. This is merely something which exists at compile time and will provide the proof that T is a subtype of S if we wanted to. Scala 3 has dependent function types. Now these are in many ways a substitute for existentials, or more complicated existentials. How many people have come across, either deliberately or accidentally, existential types? Not that many. You've had happy lives. Existentials are generally a sign of problems to come. If we wanted to write a type in Scala 2 for a default type class, now a default type class will give a default value for that particular type. So default of int will give you a 0, default of string will probably give you an empty string. The type for the get method of that default, or the get default method, would look something like this. For a default of int, it would give you an int. For a default of string, it would give you a string. And therefore, for a default of t, it would give you a t. For some t, for some choice of t, assuming that type class instance exists. So this is possible to write in Scala 2. This is not valid in Scala 3. But we do get this better syntax. This is a type, but we can have a very lightweight syntax for defining a value within that. That is a type default, and we can access a t value corresponding to the default from within that, and we can refer to the x that is introduced here. So more readable, less weird syntax, less scary, I hope. And hopefully easier to work with if you do end up in a situation where you have existentials. So a couple of simpler examples to finish up. Say for equality. This sort of code will no longer compile. If you want to check whether an integer value is equal to the string 42, that's just a straight error now. That will not compile. Maybe the most exciting feature, if, then, else. We have the then keyword. So no longer will you write this, you will write this. If a equals 0, then nil. Else list 1, 2, 3. Not maybe the most dramatic change, but it's one that I know Martin has wanted for a long time, and apparently that's more readable. I'm not entirely sure, but it is in Scala 3. The old syntax still works as well, so it's not going to be deprecated anytime soon, but I think this will be the preferred syntax in the future. And then I've got a little section at the end, which is more of an honourable mention of principal metaprogramming, because this is a huge area for Scala 3. Scala 2 had macros. How many people here have written a macro at some point? Not many, and the reason is that they're quite difficult, very prone to failure, and quite fragile. And some would say unprincipled. So Dotty introduces a few different ways of doing more principled metaprogramming. And I will just mention them. There's something called type rewriting and quotes and splices. This one I think may have been dropped from Scala 3. It was an experiment, but I think is no longer going to be there. And inline transparent methods. These are all probably terms you'll hear more of as people experiment more with the features in Scala 3. I'm not going to go into any detail on them, but Scala 3 will have much better support for metaprogramming in general, and done in a principled way, which means that we should get better tooling, we should get better support, more reliable code, and hopefully fewer of the problems and less of the scariness that happens with macros. So there's some new and exciting things in Scala 3, but we still have an entire community and an ecosystem that's running on Scala 2. And the two of these will coexist for some period of time. I think that's inevitable. Scala 3's release is about a year away. But the time they overlap, where we're having to think about which version of Scala we're targeting, is something which I think we would hope is as short as possible. I think we would like to migrate faster if we can. I do think that the risks that we end up in another situation like Python 2 and 3 are relatively small, at least in comparison. I think the fact that we have a compiler that type checks for us is the number one reason why we won't end up in that situation. We will have a Dotty compiler, Scala 3 compiler, that will be able to check our code. We're not relying on it being interpreted or relying on writing tests in order to check whether it still works with the later version. So I'm not too concerned about that. But we will have what I think will be a long-term state for many projects of being in this transition from Scala 2 to Scala 3, particularly projects that involve macros. And probably more so than we've had with the migrations from Scala 2.10 to 11, to 11 to 2.12, and coming up soon 2.12 to 2.13. I think we will have a situation where we have mixed Scala 2 and 3 builds that involve some modules which run on Scala 2, some on Scala 3. The reason for this is that Scala 3 simply cannot compile Scala 2 macros. They are written against a different compiler, and they require a lot of information about compiler internals. So moving that to Scala 3 is basically a non-starter and an opportunity to drop those more complicated macros anyway. But as of a week ago, it's confirmed that Scala 2.14 will produce and consume tasty trees, which are a bytecode level representation of the code, which will mean that Scala 2.14 will be able to read bytecode that's been produced by Dotty, and Dotty will be able to read code that's been produced by Scala 2.14. And this was agreed by the Scala Centre about a week ago, that somebody will work with Lightbend on adding tasty support into Scala 2.14 so that we do have this ability to have them running side by side. And this is huge. Without this, we would only have Scala 3 able to read methods defined in Scala 2, not the other way around. And what that would mean is, in a large project where you have many modules depending on each other, you would only be able to convert things from the leaf nodes upwards if you're migrating to Scala 3. So Scala 3 could read Scala 2, but not the other way around. It meant that you couldn't just pick a simple module in the beginning, pick a simple module in the middle, convert that to Scala 3, because nothing downstream of that would be able to read it until Tasty. So thanks to Tasty, and there's still a fair amount of work to do to develop that. With Tasty, that will be possible, and we should get the ability, maybe over a long period of time, to convert most projects to Scala 3. But in order to do this, I think that we will need to be a little bit more flexible with our builds. And I have some issues with the current system we use for publishing, where we use we typically publish to Maven Central binaries. The main concern I have is that we should be a fast-moving community, a fast-moving ecosystem that's able to push releases out very quickly, but we're not, because we're using this somewhat archaic method of distribution of binaries. If you have a Scala library, if you want to publish that, you need to make sure that anything you depend on is also published. Now, if Scala 2.13 is released in the next couple of months, a few things will happen shortly after that. The first thing is that Sebastian Duren, who maintains Scala.js, within a couple of hours of the new Scala release being tagged, he will publish Scala.js. He will make sure that he's not on vacation at that time. He will schedule time in his diary. He will know when the release is. He'll be in communication with Lightbend. And until recently, he was a university student doing a PhD at EPFL, but he would be devoting his time to making sure that he publishes as fast as possible, because everybody else depends either directly or indirectly on Scala.js. Now we are the Scala community, the Scala industry, probably runs into many hundreds of millions of dollars, maybe even billions, if you count up all of the companies that are depending very much on Scala. Now, a billion-dollar or multi-billion-dollar industry is depending on a PhD student in Switzerland to be available at the right time to publish to Sonotype in order that they can actually use the software that they need to use, so the latest versions, with the latest version of Scala as soon as possible. And this seems a little bit ridiculous. It seems ridiculous that we are burdening, either directly or indirectly, Sebastian with this task. And not just Sebastian, because after he's done that, Bill Venners will publish Scala test. He will also be aware of the release schedules. What Bill does, now, I don't know if you've met Bill or seen him speak at conferences, but Bill has contributed a huge amount to open source. He's done a huge amount of work on Scala test, which is unpaid. But Bill pays someone to release Scala test so that he doesn't have to, because it needs to be done at a very time-critical moment, because he is holding up the entire ecosystem if he doesn't. That's also wrong. And there's people elsewhere in this tree of projects we have that we are depending on probably far too much. So I think we need a fresh new approach to defining, I've said here builds, but how we interact with the entire ecosystem of Scala projects. It does need to coexist with the existing solutions. So Sonotype and Maven Central are not going to go away overnight. I don't intend to change that anytime soon. But we need things to be more flexible. And I had at this point, after I saw a talk by Runar Bjarnason where he basically said everything needs to compose. So I thought, why not have builds compose as well? Seems like a good idea. So that's the end of the sort of introductory slides. I'm going to give you a little bit of light relief where I invite you to my conference next year. I won't miss the opportunity of a captive audience a captive audience who's already self-identifying as being conference attendees. I'm running this event in September. It's a whole year away in September next year. I don't know if you've read anything about previous Scala World events, but we have hiking for the weekend, hiking and other outdoor events for the weekend before the conference, then 2 days of 2 tracks of conference talks in the Lake District, which is what you can see in the background here on a misty morning, I think. And it's a really fun event, and tickets are on sale now. I'm doing things a little bit earlier this year because we had a year off. You're all very much welcome to come, and maybe I will see some of you there in a year or so. So that's the commercial break over. And I would like to demonstrate something else to you, Fury. I've been working on my solution to some of these problems with the ecosystem in the form of a build tool or dependency manager, which I'm calling Fury, which I have named after my experience with other build tools. And it would probably take me longer than I have to explain it in an organized manner. So what I'm going to do is I'm just going to do a demo. Can everybody see that? This is my console. I'm just going to demonstrate what I imagine using Fury would be like for an average user in a few months when it's released, maybe a couple of months.
Can you zoom in just a little bit?
No.
Okay.
This is actually selected as huge.
That's good. Okay.
Yeah, sorry. This always happens. You should see it when it's on unreadable. So I'm just going to create a new workspace with some projects and demonstrate the sort of things you might do if you were using Fury. And let's just create a new directory for Scala up north, sun. And empty directory, I'm just going to initialize it with Fury, and we get some options here with tab completion, and I'm just going to call init. Oh, and it's asking for my GPG password because it is initializing a new Git repository. So I've created what I'm calling a workspace. It's managed by Git. There's a file that's been created there. Don't worry about what's in that file for the moment, but what I'm going to do is I'm going to create a new project. So I just add the project, and let's just create a website. So we've created the website project, and we're told that the current project is now website. And a project is probably very much like your whatever you feel a project to be. It's got a license, it's got a name. It's more or less equivalent to a repository on Git. And I want to create a module in that. So I'm going to add a new module called, I can't tab complete something that I'm entering myself, can I? Let's call it backend. And a module is effectively an invocation of the compiler. So I'm going to add several modules, and they're going to have dependencies between them. And each one will involve invoking the compiler. So I've got my backend. Let's add some sources. So let's create a source directory called backend. And I'm going to create a front end as well, so let's do that. We're only going to have 2 modules to begin with. And let's edit the backend file. So this is going to be website. I'm going to keep it really, really simple. Just one barely existent object called backend, just enough so that the compiler's got something to do. And what I'm going to do is that source I've just added, that file, I'm going to associate that with the module I've just created. Now the current module is backend, so all I need to do is say source, add, and then tab completion will give me a link to the only directory that contains any source, any Scala source. So I've added that source that's now associated with the module. And if I list the modules, there's only one. And this gives us an overview of what we're defining here. We have a module, that's its name, it's a library. It has some sources. I haven't added any binaries, but I could. Don't have a compiler yet, and there's no parameters to the compiler, which we don't have. So I think what I would like to do is add another module to make this a little bit more interesting. And let's call that front end. And the front end will depend on the back end. So let's add a dependency. So we've now got the current module set to front end, and if we add a dependency on backend. So you see that everything I do, we get tab completion. It's offering me suggestions that make it easy for me to specify the structure I'm trying to define. This little arrow here points to what is the current module. So any changes I make where I don't specify explicitly the module or the project will default to this one here. We've got no sources, so let's we have no front end sources. So let's add some sources. Let's add something like we're going to use the same package. So let's write some Scala. So a very simple enumeration there. And of course I need to add that source to the module. So I'm going to add, now we get tab completion offering 2 possibilities here, and we were modifying the front end, so we add that source to the front end. Okay. So we've got dependencies, we've got sources. What we don't have is a compiler. So what I'm going to do, I've got by default with Fury you get no compiler out of the box. So you have to pull in a compiler from somewhere, and the way we're going to do that is we're going to import an overlay, another workspace that someone else has defined, in this case me, but import an overlay from Git that provides us with other libraries, modules, things we can depend on, including compilers. So I'm going to do that by adding, first of all, a repository, and I'm going to use this shorthand, which is GitHub on the Propensive, which is my account, and the repository is called base, and within that I'm going to import from that repository the 2.12.6 schema. Don't worry about what that means, but it's going to pull in and make available to us a compiler, hopefully. If this worked, and it depends on my network connection. Okay, so now we have, in our workspace, we have not only the project we defined ourselves, website, but we additionally have the projects Dotty and Scala, which were imported from this repository. And what I can do is I can update these modules. So let's update front end to have the compiler Scala, and we'll do the same with the back end. So there we are, two projects, two modules in this project, depending on each other with compilers. I could build them, but they weren't very interesting. I think what I might like to do is add some more interesting dependencies. So I'm going to add another repository, and that repository will contain some more definitions of projects that I've worked on, other libraries, and what I'm going to do is then import some of the, then depend on some of those as well. So let's pull in Propensive overlay. I'm just going to rename it to prop for conciseness. Say again? I always do that. There we are, thank you. Now, I will now demonstrate a slight bug, which we've got a bigger bug. We've got a bigger bug that it hasn't actually. It's not the bug I expected. Maybe it's still busy cloning the repository. No, it should have the. Oh no, it's not a bug at all. It's just I forgot to do something. I added a link to the repository, and there is the list of the repositories we have associated with our workspace. These are Git repositories like any other, and this is the base we imported with the compilers, and this is the overlay which we called prop, and this is the local one, which is just the repository we started with, the sun directory. What I didn't do, having associated the workspace with the repository and tracking the master branch and with that commit, what I didn't do is import the workspace into my own. So I am going to import prop default. By the way, you can see what else we could import here. We could import the 2.11.11 or 2.13.0 milestone 6 schemas of the other repository. And we'd get different compilers in those cases, but I'm going to import the default schema. There's only one in prop, and hopefully this will now show a large number of projects which are available to depend on. And in our hypothetical website project, which is defined here, excuse me, I would like to add a dependency on, let's see, Guillotine. Guillotine is one of my favorite projects. It's for executing stuff. So I've added a dependency on guillotine. Let's add another dependency on, what else? Magnolia. And how about kaleidoscope as well? So you might be adding things like Circe or Shapeless like this. You would import a repository that contains a build definition, a workspace, and you would then have available these projects to depend on. So I've got all of these here, and I think now is probably a good time to try and build this. Does it seem reasonable? I've written the code, I've added the dependencies. Yeah, let's try it. So I'll just run Fury. And what this will do is it will call the compiler on each of these modules and all of the dependencies, and it will build them. So that's a little graph of the dependencies between them. So my front end depends on Guillotine, it depends on Magnolia, it depends on Kaleidoscope, and it depends on the back end. That's what these are. And then these obviously pull in more and more different other projects as necessary. This is using Bloop to do the compilation. Now this is an entirely Scala 2 based project. What I would like to do is demonstrate that we can actually have a Dotty project as well. And I mentioned in the slides that it's likely we will have builds which need to coexist, where we're maintaining two different versions or slight variants of the same build for an extended period of time. And this is where schemas come in. Schemas are my approach to doing cross-building, and I think they're going to be a useful way to allow us to specify and maintain these. So what I will do is add a new schema, I think. Add, and we're going to call it Dotty. So this is going to be the Dotty schema. This is now a complete copy of the workspace, and I'm going to make some slight variations to just the Dotty branch of that. So this is the same, but what I want to do is change the compiler of the front end from the Scala compiler to the Dotty compiler. So I'm going to set the compiler to Dotty. Oh, I didn't want to do that, because that will change it globally to all schemas, so I'll just undo that. What I want to do is change it to in just the schema. Oh, there's a real bug. It's only a bug with tab completion, though. Don't worry. Just in Dotty. So in the Dotty schema, the compiler is Dotty. In the default schema, the compiler is still Scala. Okay. Now, one very useful thing we can do, especially if you're maintaining builds or trying to understand them, is to get a diff of the differences. And I can just call diff with the default schema, and it will tell me all of the things that are different. So it's got a different name, a different ID, and the front-end module inside the website project, the compiler in the Dotty schema is called Dotty, in the Scala schema is called Scala. So we get this advantage because I'm using a pure data format to represent the builds. I'm not needing to compile and then execute some code in order just to work out what the build is going to do. It's data. It's distributed as data, it's shared as data, it's imported as data, and we can analyze it as data, and we can do that fast. So that's why I can do this. I'm going to make one more change. I'm going to copy the front end source to Dotty, and let's just modify that so that we use the new syntax. So the way we write this in Dotty is enum door case open closed jar. We can get rid of that. So I'm going to change. I want to change the source to delete in the schema Dotty. I've still got this bug. I'm going to delete the source front end, and I'm going to add in the schema dotty the source front end dotty. So I'm using a different source directory, different sources, just for the dotty schema, just for this module. And if we do the diff again, we now see that this value is the front end dotty is missing in the default schema, and front end is missing in the dotty schema, which I think is what we would expect. And if we build it again, that was building different sources. And just to prove that, hopefully just to prove that, if we edit this and let's say I make a mistake, I'm going to accidentally delete that comma. If we run this again, we get an error which is a dotty error. This is some of the better error reporting you get in dotty, so this is not a, hopefully this is proof that this is not a Scala error. So we are now maintaining two different versions of the build, one in Scala 2, one in dotty. We've got the tools to do that. It's hopefully very, very easy. One last thing we might want to do is share this workspace with other people. You saw that I imported my own overlay of projects. You saw that I imported a base overlay with compilers. I want to share this website project so that other people can depend on it. And what I don't want to do is have to depend on other people to publish to Sonatype, to publish binaries first. So my first step, I'm going to use the hub command to create a new repository in my workspace, in my account on GitHub. And let's just call it Sun, and that will go off to GitHub. This is just saving me from going into the GitHub website and adding this. And having done that, I can publish it with the workspace publish command. Now that needs a couple of things. It needs a tag, so let's call it v1.0, and it needs a key, which is going to look at my GPG installation, and it sees that I have a few different keys here. I'm going to use this one, which will sign the build before pushing it up to GitHub. And that is now available on GitHub. If you go to github/propensive/sun, you will see that that is now published. And in another project, that could be that could be imported as a dependency. And I think I am more or less out of time. Do I have time for questions?
I think we're going to have to close now and get to answering questions during the breaks.
Okay. One last thing. I would like to make a very tiny announcement, which is that Fury now has a website, which I launched this morning at fury.build, and there is some there are some frequently asked questions around there. It's pretty basic. It's work in progress. There will be errors, but it should give you an idea of. It also contains lies. That's a problem. So it says you can install Fury. It's not released yet, but when you do want to install it, it will be a matter of running this command here. But have a look at the website. If you have questions, they will probably be answered there. Hopefully, at least partially truthfully. Okay, I'm done. Thank you.